sine wave on the oscilloscope. We're going to zoom in on the measurement quantities, so we'll monitor those. And we see 100 kilohertz, 200 millivolts peak to peak, which gives us approximately 70 millivolts RMS. Be very careful to measure the voltage on your scope. Do not rely on the arbitrary waveform generator display, because that is affected by internal settings, so depend on your scope. Make sure also your scope probe, which is identified by pushing the button 1, is set to 1 to 1. This is important because that changes the readings. Now we'll look at the spectrum analyzer. The spectrum analyzer is not a complex instrument, but it does take some time to get used to how it operates. First off, we always start by pushing the green button on the spectrum analyzer. This is the preset button. This allows us to determine exactly where we are operating. When the spectrum analyzer first turns on, you can see that the horizontal axis is set to be 0 hertz to 1500 megahertz. That is the settings that are shown for the start and the stop frequencies. The vertical axis is set to be 0.0 dBm at the top. The divisions are 10 dB per division. So if 0 is at the top, minus 10 dBm is the first line, minus 20, minus 30, minus 40, minus 50, minus 60, minus 70, minus 80 dBm at the bottom. We are looking to have a signal of 100 kilohertz and minus 10 dBm. So let's first set up the spectrum to display a signals from 0 to 1 megahertz. There are many ways to do that, but this is by far the easiest way we have learned over the years. First thing, after pushing the green button, press peak search. When you press peak search, you will notice a small diamond appearing on the signal. That tells us that that is the signal we are tracking. So look for the marker or the diamond. Then we press signal track. Signal track looks for the largest signal in the display area and moves it to the center. Now, we have nothing connected to the spectrum analyzer, so what is being displayed? Well, the spectrum analyzer moves frequencies around. In order that you know or have a reference frequency, the spectrum analyzer inserts a known frequency. The known frequency it inserts is a 0 hertz reference signal. So the signal being shown is 0 hertz. Nothing is connected, so nothing is there except a 0 hertz marker. That is not a true signal, it's a reference for us. Okay, setting up for 1 megahertz of frequencies. First thing we do, span. Use the span button. This determines the horizontal axis. We will set it up to 1 megahertz, and the system goes through an auto zoom process. Now when we look into the left and right, the center frequency is minus 465 kilohertz and the span is 1 megahertz. Now the center is reading minus 452.5 kilohertz in this case. We already said that this is a 0 frequency marker. What is up with this? Well, the spectrum analyzer is meant for hundreds of megahertz to gigahertz working. And so the 0 indicator can be off by some amount. This is just a value you must ignore and work with and treat it as 0. Don't count on that value being the same on every spectrum analyzer. It's related to the individual spectrum analyzer, and it will change as the spectrum analyzer heats up. So do not use the zero frequency marker frequency. This is what we will do. First off, we will turn off signal track. By turning off signal track, we can now move, by pushing frequency, the marker to the left. We know that this signal is a zero frequency marker because nothing is connected to the spectrum analyzer. So, if 0 is now on the left-hand side and the span is 1 megahertz, this means that the right-hand side must be 1 megahertz, and each square represents 100 kilohertz. 100, 200, 300, 400, 500, 600, 700, 800, 900 kilohertz, 1 megahertz. Now we are ready to input our signal from the arbitrary waveform generator. When we input the signal into the RF signal, we can see immediately a signal pops up to the right of the 0 indicator. Is it in the right place? Well, the span is 0 to 1 megahertz, so the first line, vertical line, represents 100 kilohertz. That's very close. And the first line down represents minus 10 dBm, and we see that the signal is pretty close. If we want to look at the exact value, we can use the peak search button, go to the next peak right, and we see at the top left that the signal is reading minus 9.1 dBm. Not exactly minus 10 dBm, but in this case, close enough. That is how we set up the spectrum analyzer to read signals from our arbitrary waveform generator. Again, let's do a quick review. Preset. You can always use preset, puts you in the right position. Peak search, signal track, set your span 1 megahertz. Auto zooms in, turn off signal track, use the frequency button to move the 0 indicator to the left. Close enough, and we have our display. Just to confirm that this is working, as I will change the arbitrary waveform frequency from 100 kilohertz to 1 megahertz in 100 kilohertz steps. So it is currently at 100 kilohertz, 200 kilohertz, 300, 400, 500, 600, 700, 800, 900, 1 megahertz. The 1 megahertz is indicated because it's a span of 1 megahertz, and the 0 indicator is on the left-hand side, and that's how we know it is 1 megahertz. We don't have a direct marker reading of the frequency of the signal.